Okay, so up here, you're going to put today's date, which is the 12th. So 8/12. And this is still lesson 4. Module 1. And then this is going to be page 6. Okay, so the learning target is the same. Okay, solve quadratics so copy that down. Solve quadratics by completing the square. Quadratics by completing the square. Okay, so we're going to do about 3 examples here. So let's see, first one, x squared plus 4x plus 7 equals 0. Now, if we tried to graph that, or if we tried to factor it, we can't do either one of those. Okay. All right, so when we talk about, there's these things, each one of the variables in there, it has a name. Okay, the one with the square, this is called your quadratic term. Okay, this is called the linear term. And this is called the constant. Okay, so if I talk about the quadratic term, I'm talking about x squared. All right. So the first thing that we did yesterday was we took the constant and moved it to the other side. So I'm just going to say move 7 to the other side. All right, so now we end up with x squared plus 4x equals -7. All right, now in order for you to be able to complete the square, okay, you have got to, here's what has to happen. The quadratic has to be a perfect square, and the linear term has to be even. Okay, so what you got to have right here is that we need quadratic term to be perfect square. So that's quadratic term to be a perfect square. Well, I'll just put it like this. Let's see. Need quadratic term to be a perfect square. and you need the linear term to be even. Okay, so you can't complete the square until you have those. That's like the prerequisites. Before you can complete the square, you got to have a quadratic term that's a perfect square and a linear term that's even. Okay, so do you have those? Look right here. Is that value a perfect square? Yeah, there's a 1 there. 1 is a perfect square. Okay? And 4 is even. Remember, there's a 1 there, even though we don't see it. Okay, so this is a perfect square. So we don't have to do anything to this equation. It's ready to roll. All right, so once you've satisfied this, okay, these are both done, check, check. Now you can complete the square. Okay, so over here what I'm going to do is just sketch myself a square. So we got these ready. So now let's complete the square. So let's see, we did this step first. Okay. Then we did this step second. Didn't have to do anything to that. And now third, complete the square. Okay. All right. Okay, so now all we got to do is draw our little our square and come up with your numbers. Okay. Quadratic term goes there. Linear term, once we figure it out, it's going to go there. And then these were the two terms that had to add up to be 4x. And when we did this yesterday, guys, the two terms that are inside that orange boxes, they're always the same. Okay. All right, so let's see, I'm going to color code this. Got it. So this goes in the right here. So this is going to be x squared. Now, I need two terms that add up to 4x, and remember from yesterday, they've got to be the same number, 2x and 2x. So this would be 2x, and this would be 2x. And now you can figure out what goes outside your box. Okay, so this would have to be an x. This would have to be an x. How about this? A 2, because x times 2, and this a 2. So this missing number here is 4. So this is going to get, I'm going to add that to both sides. Alright, so up here, going back to our equation, I'm going to add 4 to both sides. So let's see. Okay, so I'm going to add 4 to the left and add 4 to the right. All right, now you're going to factor and solve. So when I write LHS, left hand side, and the numbers outside your box are what it factors into, so that's easy. This is going to be x plus 2 squared, and over here on the right, negative 3. Okay, and then to finish it up, solve the resulting equation. Okay, so to solve this, square root both sides. So when I square root the left side, that's just going to become x plus 2. And I got to square root the right side. So this would be x plus 2. And this is negative square root 3. Okay, then we're going to subtract 2. Okay, and that's going to give me x equals negative 2 plus the square root of negative 3. Okay, now actually when you do the square root of a number, there's 2 roots to it. There's a positive and a negative root. So notice what I'm going to write here. Plus or minus the square root of negative 3. Okay, and now finally, simplify the root of negative 3. Okay, so I could break that up into square root of negative 1 times the square root of positive 3, which is I times root 3. Plus or minus I root 3. Now that's actually 2 different numbers, guys. Okay, this is your answer. That's your solution. You can just leave it like that. But you've got to realize this is really 2 numbers. Okay, one solution is negative 2 plus I root 3. And the other solution is negative 2 minus I root 3. Because there's 2 of them. All right, so there's an example that we didn't have to do anything to the equation. It was ready to go. Didn't have to do anything. Like a microwave dinner. You just pop it in the microwave and eat it. This one, we didn't have to do anything to it. We just could complete the square. All right, now the next one, you got to do a little bit of prep work to it before you can complete the square. All right, so let's do that. Okay, so this one is 2x squared plus 6x plus 9 equals 0. And you're going to solve it just like the last one. Okay, so if we go down our list, move the constant to the other side. Okay, now you got to figure, it's ready to go. You got to check. Is the quadratic term a perfect square? Is the linear term even? So when I look at this, I'm going to look at this number. Okay, that's even, so check. And then this number, perfect square. Nope. All right, so you can't complete the square until you change that. So this almost passed. It had the linear term was even. Okay, so check. Okay, but the quadratic term, not a perfect square. All right, so here's what you do. What could you multiply it by so that it would be a perfect square? 2. So if I multiplied 2, I could use lots of numbers. I could multiply it by 2 and make it a 4. Okay, I could multiply it by 50 and make it 100. That's a perfect square. Okay, I could multiply it by 20 or 64. I could multiply it by 32. That would make it a perfect square. All right. So what I'm going to do over here is I'm going to make this a perfect square. I am going to multiply all the terms by 2. And so everything gets multiplied by 2. Right? So 2, and then that whole side gets multiplied by 2, and this side gets multiplied by 2. And now I'm ready to roll. Okay, so we did that so that this would be a perfect square. Two times 6 is not 8. Okay. And so check, perfect square. Check. Even. So now it's ready to roll. Okay, now go ahead and complete the square. Okay. So after we did this, now our next step is complete the square. So sometimes you got to do a little bit of work to it in order to get it to be in the right format so that you can do this. Okay, so this guy's got to add up to be 12. Go ahead. Okay, this cat goes right here. All right, what's missing now? What's going to be my orange boxes? How much? Yep. 6x, 6x. So this is going to be a 3 and a 3, and that's a 9. Now I know it seems like a lot, but this is so much easier than the way that I learned. So I'm going to add 9, add 9. Pardon me? Question? Good to go? Yeah. Where'd I get what from? Oh, because, all right, when I filled in, when we determined that that was a 6, so are you okay on how we got that? So then you ask yourself, all right, 2x times what is 6x? 3. And the same thing's there. Okay, now we can factor. So 2x plus 3 squared equals -9. And now the steps are the same. Take the square root and isolate x. Okay, move the 3 over. Now I'm going to simplify root 9, negative root 9. So that's going to be plus or minus 3i. Divide by 2. And there's your two roots. -3 plus 3i divided by 2. -3 minus 3i divided by 2. And you can leave it, you can leave it like that, or you can write it like this. Negative plus or minus 3i over 2. They're the same thing. Why did I add this 9 right here? Okay, so this term, 3 times 3, that's 9. So whatever you get for that number, you add to both sides. That's where that 9 came from. Now, that's how you got the number. What it does is, for something to be a perfect square trinomial, when we did them yesterday, okay, everything that was a perfect square trinomial, do you notice that this is a perfect square? Okay, the quadratic term's a perfect square, and the constant's a perfect square. Perfect square, perfect square, perfect square, perfect square. Okay, so as being part of a perfect square trinomial, the quadratic term needs to be perfect, and the constant needs to be perfect, and the linear needs to be even. Yes? Where did I get the 2 3s? Okay, let's see. Okay, these 3s right here. Is that what you're talking about? Okay. So when I filled in this chart here, we determined that this was 6x and 6x. Are you okay with that part? All right, so then you ask yourself, what would you multiply 2x by to create 6x? 3. See, multiply those two, you get 6x. 2x times 3 gives you 6x. Okay? All right, so that's where the 3's came from. All right, so that one you had to do a little bit of prep work in order to make it work. Okay, now here's the next one. Okay, so let's see, I'm going to put this on the next page here. So this is page 7, and this is still lesson 4, mod 1, and this is 8:12. Okay, now I'm going to give you one where you've got to do more work to it before you can think about completing the square. Okay. So, yep. All right. So here it is. This would be number 3. All right, 5x squared minus 3x plus 17 equals 9. You need to follow what I'm doing to see if you can understand what Well, what I'm saying is, while I'm doing this, you need to be working it out so you're following along. You're going to have a hard time doing it because you're not listening while I'm doing it. All right. Yes. Yep. I'm going to post these. I'm going to take a picture of them just like the other ones. Okay, so now we got to move the constant. Okay, so we subtract 17 from both sides. Right, and I get, this would be negative 8. So I'll put like a little commentary over here. Okay. Are you Daniela? Did you come in late? Okay, you need to tell me because I marked you absent. And there's been all sorts of emails about attendance, so guys, if you come in late, let me know, because sometimes I have no idea, and then you mark late or absent. Okay, so Daniela, remind me before you leave today. All right, so we subtracted the constant from both sides. All right. Now you got to decide, is it ready to go? So you ask yourself, okay, is that a perfect square? And then you ask yourself, is this even? And the answer to both of those is no. All right, so now you got to do a little bit of strategizing. You gotta employ some strategery. Okay, so now what you want to think is, what could I multiply 5 by? Yes.
4.
4? Okay, let's see. What could I multiply 5x by, 5x squared, to make it a perfect square? Pardon me?
2.
Well, if I multiply it by 2, it would be 10x squared. Say it a little louder.
5.
Yep, 5.
3 would still be odd.
Okay, yep. All right, so here what we're going to do is, our answer is multiply it by 5. Okay, so everything gets multiplied by 5. So my next step looks like this. I multiply that side by 5 and that side by 5. Okay, so now I get 25x squared, okay, minus 15x equals negative 40. All right, now we're almost there, because now this is a perfect square, but that's odd, and we want it to be even. That number there has got to be an even number. Exactly, yep. Perfect square, yep. So now we're going to have to multiply both sides, or multiply everything. I'm going to multiply all the terms by, what did you say, 4? By 4 to make 15x even. So you had to multiply two things. All right, and then it's ready to roll. Okay, so I'm this whole thing gets multiplied by 4, that gets multiplied by 4. And now we got 100x squared minus 60x equals negative 160. Now it's ready to roll. Okay, now we got exactly what we want. Perfect square and even. Okay, so now we can complete the square. Believe me, if we had done this the old school way, there'd be so many fractions right now on your paper, you'd stab your eyeballs out. Yeah, go ahead. Okay, here we go. Whoops. Okay, so go ahead and fill out your box. Okay, and these two got to add up to negative 60. Okay, Dimitri, what are we going to have here? What's going to have to go to the right and above this box? Dimitri, answer. What times itself is 100x squared? Pardon me? Dimitri. Oh, I'm sorry. I want him to answer. Do you see why? Okay. So this would be 10x, and this would be 10x. Okay, now the two orange numbers have to add up to be negative 60 and be the same, Dimitri. What would they be? Yep. Negative 30, negative 30. All right, so now to get these missing numbers here, what would you multiply 10x by to make negative 30x? Yep, so that's negative 3, and that's negative 3. And the green number is now positive 9. Okay, so I'm going to add 9 to both sides. Okay, that's where that came from. And now it's just, okay, 10x minus 3 squared equals negative 151. Okay. And there's your answer. That is a complicated completing the square method formula. But I tell you what, this right here that I showed you makes the old school way look like impossible. So this is a much more intuitive, easy way to do it. And you can write it either way, and it's fine. Anything I did there, I didn't write down every single step on that last part. Anything you need me to go over? All right, so we didn't get a chance to get to the homework because this took a little bit of time, but it's okay. This is good stuff.
Okay, the absence of divided today. That's gonna get cleared up, right?
Today?
Yeah,
Yesterday? I can't hear you.